This lesson is section 6.5 in the book. It is on kites and trapezoids, specifically isosceles trapezoids. The definition of an isosceles trapezoid is a trapezoid whose non-parallel sides are congruent. This would be an example of an isosceles trapezoid where one pair of sides is parallel, the other pair of sides is congruent. This is a regular trapezoid. Notice one pair of sides is parallel, but these two sides would not be congruent to each other. The pieces of trapezoids are base angles. There's a pair of base angles here. There's also a pair of base angles up here. Since the parallel sides are considered the bases, then the pair of angles that sit at those bases are called base angles. Same thing in an isosceles trapezoid. Your parallel sides are called your bases, and then you have a pair of base angles up at the top and a pair of base angles down at the bottom. So what are the properties that make an isosceles trapezoid special besides, by definition, the sides are congruent? The pair of base angles in an isosceles trapezoid are congruent, which means this angle is congruent to this angle, and this angle down here would be congruent to this angle down here. The other thing that makes an isosceles trapezoid special is that the diagonals, if you draw the diagonals in a isosceles trapezoid, the diagonal here is going to be the same length as the diagonal here. They are congruent to each other. Kites, by definition, are a quadrilateral, so it's a four-sided figure, and it has two pairs of congruent adjacent sides, but no opposite sides are congruent. That's what separates a kite from a rhombus. The two pairs of adjacent sides are congruent, so this side is congruent to this side. They are adjacent and they are congruent, and these two down here would also be congruent to each other, and they would be adjacent. The trick is that these two cannot be the same as these two. That's what the second part of the definition is about, that no opposite sides are congruent. There are two properties that make a kite special. The diagonals are perpendicular, just as in the rhombus. When you draw in the diagonals, they intersect at the middle at 90 degrees. The other thing that makes a kite special is that the longer of the diagonals bisects its angles. So this angle would be congruent to this angle, and this angle would be congruent to this angle. That creates a line of symmetry. So you could say that this half of the kite is congruent to this half of the kite. Some examples that you may see that involve isosceles trapezoids are an example like this, given that this diagonal is equal to 7y minus 3, and this diagonal is equal to 4y plus 6. We know by our properties of isosceles trapezoids that our diagonals are congruent. So we would have to set up the equation that 7y minus 3 would have to be equal to 4y plus 6. We would do our algebra, minus our 4y over to this side, and we would get 3y. And then we would add 3 over to this side to our 6 and get 9. We would divide by 3, and y is 3. If you just want to know what the variable is, you're done. If you want to know what the length of the diagonal is, you have to take your value of 3 and plug it back in. 7 times 3 is 21, minus 3 is 18. 4 times 3 is 12, plus 6 is 18. We would hope that they would come out equal. That's how we set up the problem. Another example would be if I give you one of your base angles, you should be able to figure out the other three. Since it's an isosceles trapezoid, We know that this one's 49, so therefore angle 1 would have to be 49. There's a couple of ways you could go about this. Since these two lines are parallel and this acts as a transversal, these two lines or these two angles would have to be supplementary. So you could figure out what's left of 49 to get to 180. So you do 180 minus 49 and you would get 120, 131 would be your angle measure here. And then since it's isosceles, this angle here would also have to be 131. Examples for kites. Given our properties, we know that the diagonals, since they're drawn in here, form 90 degrees. So we would know that angle 1 is 90 degrees. We would know that the longer diagonal bisects or cuts in half the angles up at the top. So if this side is 64, we know that this side is 64, leaving angle 2, 90 plus 64 is 154, leaving 26 to be the measure of angle 2 because the three angles add up to 180 in a triangle. The other example is that when you draw in your line or when you draw in your longer diagonal, it is a line of symmetry for the kite. Therefore, this whole angle has to be equal to this whole angle. So since it's a four-sided figure, we know that the angles add up to 360. We would have to minus off what we already have. So we'd have to minus off 126, and that would leave us with 234 degrees. And to figure out what each one of those is, since they're the same, we would simply divide it by 2. And we would get 117 degrees. That concludes this lesson on isosceles trapezoids and kites. Your homework for your classes are as follows.